I want to talk a little bit about inequalities and solving inequalities. First of all, this is really important, as you can see from the middle of the screen. If you have a non-linear inequality, basically we need to pretend that it is an equality, pretend that we have an equal sign, solve it as though it has an equal sign, but then we have to do test points, okay? So what I mean by that is over here on the left, all of these. Okay, well, this first one for sure is linear. Linear meaning degree 1, so we don't have any x squared or x to the -5th or square root of x or anything. So this first one is linear. These next two I'm kind of calling linear-ish. If we were to graph those, like if we move everything to one side and call it y equals, we're going to have a v, because we know that an absolute value shape makes a v. So they're not strictly linear, but they are, we can think of them as piecewise functions where each piece is linear, okay? So I'm going to group those together with linear, in the linear group. And I believe in the chapter 0 reference, I showed a shortcut for how to solve nonlinear inequalities, absolute value inequalities if you have just a single linear piece inside the absolute value. Let me know if I didn't and I can make something. Okay, and then these down here are nonlinear. This first one is nonlinear because we have an x in the denominator. The next one's nonlinear because we have an x squared. If we expand x plus 2 to the second, we end up with an x squared term. And this last one is composed of two linear pieces. However, when we have two absolute values on both sides of the equation, we really need to treat that like nonlinear. And I'm going to show you actually two different ways to solve that particular one, okay? But first of all, I want to look at number 33, and I believe this is from section 0.2, maybe 0.3, but I'm pretty sure it's 0.2. All right, so for this first one, we have x plus 1 times x squared plus 2x minus 7 is greater than or equal to x squared minus 1. Because this is a nonlinear inequality, I am going to ignore that there is a greater than or equal to. I'm going to pretend it's an equal sign. I'm going to solve it like an equation, but then I'm going to use those solutions to the equation to do test points on a number line. Okay, so I'm going to come over here. Now, as far as my options for solving this, we could distribute the x plus 1 to the x squared plus 2x minus 7, and then move everything to one side, and then factor, set it equal to 0, etc. But because we have a factor of x minus 1, and because we have an x squared minus 1, which I know I can factor on that side, I'm actually going to go ahead and factor first. So I'm going to write this as x plus 1 times x squared plus 2x minus 7, and I'm going to do two steps in one. I'm going to subtract this whole thing over to the other side, so I'm going to write minus x plus 1 times x minus 1. So this is me factoring x squared minus 1, but then I also moved it all to one side, and so this is now equal to 0, okay? And then from here, I can factor an x plus 1 from both pieces, and I have x squared, and now I have plus 2x minus x, so plus 1x, and then negative 7 minus negative 1, so negative 7 plus 1 is negative 6, equals 0. If you want to distribute first, no problem, but I'm trying to do it in as few steps as possible, okay? And so now I'm going to look at this piece to see if I can factor that. Oh, something I want to back up here. I cannot just divide both sides of the equation by x plus 1. If you divide by something that has a variable in it, you are eliminating a possible solution, or at least a possible critical point. Okay, so I need to keep the x plus 1 in there because it has a variable. It's not like dividing both sides of the equation by 2, which doesn't change anything. Because there's an x, I have a solution of x equals negative 1 that I need to consider. Okay, so I'm leaving that there as a factor. Okay, so then I've got, to factor this further, I have x plus 1, and I'm looking to see how this can factor. This is, sorry, there's a phone ringing, x plus 3 times x minus 2. Okay, and now because this is an equation, oh, that was a bad arrow. Because this is an equation, I can use the zero product rule. Remember, zero product rule says if we have product of two or more factors equals 0, at least one factor itself has to be 0. Remember, that does not work for inequalities, which is why we have this big statement up here, okay? So, setting each of those factors equal to 0, we get x equals -1, -3, and +2. Now, those are not the solutions because if you remember, we started with an inequality where we have a greater than, okay? So, what I'm going to do then is I'm going to put these 3 points on the number line, and I'm going to do test points around those to see what is part of my actual original solution, okay? So let's do this over here. Okay, so here's my number line. Please make sure you put them in order from smallest to greatest. Okay, so -3, -1, and 2. And it does not matter if they're evenly spaced out or not. We just need to know that there's room for numbers in between those. Okay, now as far as my test points, like what I'm plugging this into, let's kind of go back for a second and look at where we started messing with the inequality part. So this first statement, I changed it. If you remember, from here to this statement right here, I moved this part over. Basically, I subtracted all of the quantity x squared minus 1 and moved that to the left. Adding and subtracting does not mess with inequality signs, okay? So this statement is still actually equivalent to the original statement if I go back and make that the greater than or equal to sign, okay? And then moving from this statement to the next line, again, I have done some factoring, but I have not. Remember, the things that mess with inequalities are like multiplying both sides by a negative or dividing by a negative or taking the square root or something like that. So from this step to this step, I haven't done anything yet. Same thing here. So really, what I'm going to do, because I haven't multiplied or divided by any negatives or taken any square roots, I'm going to keep my greater than or equal to all the way down to this last statement here. And then when I plug numbers in to do test points to see if they are part of our solution, I'm going to plug into this statement right here, okay? Can you, if you're unsure, plug it into the original statement to see if it's true or not, but I'm going to go ahead and use this one, okay? So, if I plug something that is to the left of -3 into this statement, let me, actually just to give myself some more room, I'm going to rewrite this. So I'm not changing anything, just rewriting. Okay, so if I plug something to the left of -3, this factor is going to give me a negative, this factor is going to give me a negative, this factor is going to be a negative. Negative times negative times negative is not greater than or equal to 0, so that is not part of my solution, okay? In between -3 and negative, and it doesn't, okay, your teachers in the past probably had you actually evaluate with a number, so they said like plug in -4 and then you get some number. It doesn't matter how big or how small the number is. All we care about is that it is negative, okay? So just knowing that the product of 3 negatives is negative is enough for me right there, okay? And then in between -3 and -1, so here if you want to use a real number like -2, that's fine. This would be a negative factor. X plus 3 when x is greater than -3 is no longer negative. That is now a positive. This one is still negative. So now I have negative times negative, which is positive. That is greater than, actually I'm not going to put a plus sign there. That is greater than or equal to 0. So I'm just going to put a check mark that yes, in between this, the -3 and the -1 is part of our solution. Okay, to the right of -1, so in between -1 and 2, this first factor changes signs. So I'm going to put a plus there. This one is still positive. This is still negative. Positive times negative is negative. That is not greater than or equal to 0. And then lastly, to the right of 2, we would have positive, positive, positive for all three of these factors. That is greater than 2 or greater than 0. So anything to the right of 2 is part of our solution. So our solution is from -3 to -1 and from 2 to positive infinity. Now, for graphing this on the number line, I need to check to see if I'm using open or closed circles. because this is a greater than or equal to, I'm using closed circles. In other words, plugging -3 would make this a true statement because I would have something times 0 times something which is greater than or equal to 0. That's true. Okay, so from -3 to -1, again, -1 is part of the solution. We would have 0 greater than or equal to 0, not in between here, and then from +2, put an arrow showing that it goes to infinity. In interval notation, this is from -3 to -1. Oh, close, not open. Close brackets here. Union, and notice that there's no tail here because it's not the letter U. It's just kind of a horseshoe shape. And then 2 to positive infinity. And infinity is always open, so I use parentheses on that side. Okay, so in interval notation and graphical notation, here is our solution to part A. Okay, and I'm going to pause this here and then come back and do B and C at number 59 just because this is already a longer video than I had intended. But if you want to stop and take a whirl at B and C on your own, that would be great.